Alright, as promised, we'll go through this exam 3 prep. Might only get halfway through this video. So number 1 here, you can see finding the intercepts of asymptotes domain range from the graph of a rational function. So let's go ahead. Some of these will require a little bit of work to be done on the whiteboard, but others not. Now it says the graph of a rational function f is shown below. Assume that all the asymptotes and intercepts are shown and the graph has no holes. Okay, now the vertical asymptote looks like there is one of them, right? And it looks like it is at the x value of 2. So we will say x equals 2. And for the horizontal asymptote, we do have a dotted line here. It looks like it is at -1. So y is equal to -1, right? So the dotted line horizontally is the horizontal asymptote, vertically, vertical asymptote. Seems easy enough. The x-intercepts is when we cross the x-intercept. Now it looks like we do have one here at x is equal to -6. I don't see any other ones. And the y-intercept, of course, is when we cross the y-axis. So looks like we have one here at +3, right where my cursor is. It doesn't look like it crosses the y-axis anywhere else. And lastly, the domain. The domain and the vertical asymptote go hand in hand, right? You'll see that x equals 2, right? We cannot cross a vertical asymptote. So the domain here goes from -infinity. So let's go ahead. Domain goes from, let's do, which one do we want? -infinity all the way to +2, and then we need to jump on the other side of 2, and then we can go from 2 all the way to a +infinity, right? So we need to skip over that 2. The vertical asymptote goes with the domain, and this is always going to be true. The vertical asymptote and the domain hand in hand. Now you'll sometimes see for the horizontal asymptote, which is going to go with the range here, it's not always true. Sometimes it's true, and in this case it is true, right? And what I mean by that is if we look at -1, the y value, notice that we never cross this line. And because we never cross this line of y equals -1, it is not within our range. So we need to do the same thing and skip over it. So we have the same idea here. Nope. Oops. Let's get rid of that. Let's put our infinity back in and go over here. So same idea, -infinity all the way to -1. And we're going to skip over that -1 and go towards infinity. Right, so again, please, obviously the benefit of having a video is you can go through and rewatch. Notice again, the domain is this vertical asymptote. I don't cross it, so that's why 2 is not in our domain. The range ends up being this horizontal asymptote, and we can cross horizontal asymptotes. In this case, we do not. But you'll notice we don't have this in our range because we do not cross this line. Okay, let's move on to our next problem. Okay, problem number 2. There is finding the asymptote of a rational function where it says constant over linear, and then there's one where it says finding the asymptotes of a rational function linear over linear. We'll do both. Maybe we'll only get through 6 problems. Let's see. Now both of these come down to the same thing. What are we going to do? We're going to set this denominator, which is a 3x plus 3, equal to 0, right? That's where we get our vertical asymptote. Okay, and we also need, of course, I understand, the horizontal one. Right, so we're looking for both the vertical and the horizontal asymptote. Okay, so remember this function. I'm going to jump over to the whiteboard here shortly. Okay, so I believe I had, let's see, f of x is equal to, was it -5 or +5? It was a -5. Awesome. -5 and 3x plus 3. And now to find the vertical asymptote, we need, let's do this. We need to take our denominator and set it equal to 0. In which case, right, we're solving for x. And so we have a vertical asymptote at x equals -1. Now for our horizontal asymptote, we have some rules, right? And we had 3 rules. I'll go over one of them here, right? One of the rules is that if we have a higher degree in our numerator, or a higher degree in our denominator, so in this case, our denominator here has degree 1, right? This is a degree 1. So the degree in our denominator, I'll just say D for denominator, is greater than the degree in our numerator, right? Degree in my numerator is just degree 0, right? So 1 here is obviously greater than 0. Our rule is, if this is the case, we do have a horizontal asymptote at y equals 0. Always the case. If it has this, right? If it is this case, then we will have y equals 0. Okay, let's go ahead and jump back. And I think all we need to do is graph these, right? X equals -1 and y equals 0. X equals -1, y equals 0. Boom. Let's go ahead and check. Did we get it right? We got it right. Okay. Let's move on to the next one. We'll do the same thing, except now we have linear over linear. Now, the vertical asymptote is going to be exactly the same. So remember this, write this down. The horizontal asymptote is going to be somewhat different because notice now the degree in the numerator and the denominator are the same. Okay, so let's go ahead and we'll jump back over. We have -6x minus 4 and 3x minus 3. And so we still have the case for a vertical asymptote to take our denominator and set it equal to 0. All right, so let's go ahead and just move some stuff around. Right, adding 3 to both sides and dividing by 3. Let's go ahead and make this bigger. And dividing by 3, we get x equals 1. So same idea as before. However, now we have a different case, right? So now the degree in our numerator is equal to the degree in our denominator, meaning they both have degree 1, right? If this is the case, all you're going to do is steal the coefficients from these degrees, and we get y is equal to -6/3, or in this case, -2. Right, so y is equal to -2. So we're looking at the ratio if they have the same degree. Okay, let's go back. We need x equals 1, y equals -2. So x equals 1, y equals -2. We'll go ahead and check. And boom, we're good. So 2 problems down. Let's go ahead and look at our next one. So number 3, finding horizontal and vertical asymptotes of a rational function. Quadratic, let's click. It'll be a surprise for both of us. Okay, so same idea. Nothing's changed here. Graph all the vertical, so just a scaled up version of what we were doing, right? Very similar. So just graphing the vertical and horizontal asymptotes. Feel free to write down the equation. I'm going to do the same thing. So 3x squared minus 12. Might have to jump back and forth here for a second. And I believe it's x squared plus 2x plus 2x minus 3. Okay. So exactly the same steps, right? Exactly the same steps we were doing before. right? There we go. So vertical asymptote, we will take our denominator, and guess what? Set it equal to 0. In this case, the algebra that we need here is to be able to factor, right? I need two numbers that multiply to be -3, and they add up to be a +2, in which case I need a +3 and a -1. And be careful, right, because we set each one of these pieces here individually equal to 0, which means I get x is equal to -3 and x is equal to +1. So I have two vertical asymptotes. Two vertical asymptotes. As far as our horizontal asymptote, notice that this is the same case as last time. The degree in my numerator is equal to the degree in my denominator. They're both degree 2 here. And if I have this case, I steal the coefficients. There's a 3 there, there's an arbitrary 1 here. So we have 3 over 1. So my horizontal asymptote is just going to be 3. Right, 3 over 1. So I have two vertical asymptotes, I have one horizontal asymptote. So let's go ahead and go back. We have x equals -3, +1. So we have x equals -3, +1, and we have a y of a +3. Go ahead and get rid of that. Let's go ahead and check it, and boom. All right, so still the same process. Set the denominator equal to 0 for the vertical asymptote, and then we are looking at the case, right? There's actually 3 cases. We've looked at 2 of them. Let's go back. And let's do one more here. Okay, similar, but this goes over case 3 for all the asymptotes. So we'll go ahead and do this one. So feel free to write down that function or pause the video. We have x squared plus 7x minus 3. So x squared plus 7x. Was it minus 3 or plus 3? I just read it out loud. Minus 3. All over x plus 3. And we have f of x, right? So one more time. If we're looking for vertical asymptotes, this one's straight away. We take our denominator, we set it equal to 0. We have one answer, -3. Now for our vertical, or for our horizontal asymptote, this brings us to a new case, right? So this will cover all 3 different cases. The degree of our numerator here is greater than the degree of our denominator, right? Degree of the numerator is degree 2, degree of the denominator here is degree 1, and so in this case, we have no horizontal asymptote, actually, right? Very nice case. So we only graph the vertical asymptote, which is going to be x equals -3. Uh-oh, what did I do? Oh, that is right. There is one other case here. Notice this other one. I forgot. This is known as a slant asymptote. Might have to throw out this problem. Let's see. We'll go over it. So x plus 3, there's a slant asymptote. The reason why there's a slant asymptote is because the degree here is 1 less than the numerator. So if you have the case where there's no horizontal asymptotes, that's fine. But the degree in the numerator is 1 greater than the degree in the denominator, what we can do is find what's called a slant asymptote. And what we need to do is perform some polynomial long division, or in this case, we can use synthetic division, which is what I'm going to use. So let's go back. So we have a little bit of extra work to do to find this slant asymptote. So again, this only happens if the degree in the numerator is 1 less or 1 more than the degree in the denominator. And so we're going to have to perform this, right? X squared. I'm writing this out, but I'm going to actually do the synthetic version. Right, the synthetic version here lets me take -3, right? Remember, this is x minus the value. So in this case, x minus a -3 would get me x plus 3. And we have our synthetic division here. We're stealing the coefficients 1, 7, and -3. So synthetic division, the 1 immediately comes down. We have -3 times 1, -3, 7 plus -3, +4, -1 times 4, -12, -3 plus -12, 15. So in our case, we end up with, remember this is going to be 1 degree less since we did this division. So this is x plus 4 minus 15 over x plus 3. Now we really don't care about this remainder here from our synthetic division. It is just the x plus 4 that we are considering here for our slant asymptote. Now we're going over this, but there's a good chance I'm going to throw this one out because I don't think I covered slant asymptotes, or at least I didn't cover them in detail, so there's a good chance that one's going to go. But just for the sake of this problem, we have x plus 4. So let's go ahead, we're going to go back, and we have an x plus 4. We're going to put, we need 1 dot. So at 0, because it's x plus 4, we have 0, 4, and then we can just go up 1 over 1. Let's try this again. There we go. Right, so this problem will probably get thrown out. I don't remember going over slant asymptotes, so I don't want to make you guys learn something at the last second here, but in case you are curious about the slant asymptote, I do have that in the video there. We're going to see if we can get 2 more problems in. So at least there's something for you guys to watch right in the morning. Or maybe we'll try to do 3 more? Let's see. Yeah. Alright, let's look at 4. It says graphing a rational over a constant function. Okay, I'm going to leave these 2 for you guys. The reason being is this just comes down to plugging in points, right, and drawing the vertical and horizontal asymptotes. So very similar, right? You can graph the vertical asymptote, which is a -3. In this case, the horizontal asymptote here, because the degree in the numerator is less than the degree of the denominator, we have this. So there's our asymptotes. And now what I would suggest doing is you're going to need to, what does it say? It says start by drawing the vertical and horizontal asymptotes, then plot 2 points on each piece of the graph, meaning you need to pick 2 x values on the left side and 2 x values on the right side of the vertical asymptote. So 2 values left of -3, 2 values right of -3. So I'll leave those ones for you guys. Those should both be very similar for number 4. Let's look at number 5. Okay, these ones I know people struggle with, so this is good. So some of this, we're going to have to do part of this on a whiteboard, but let's go down the line here. So we're going to read this as vertical asymptote x equals -2 and x equals 3. Let's pause, right? Immediately, I know that I have 2 of them, right? So I'm stuck between option 2, 3, and 4. Or 3, 4, and 5, because I have 2 vertical asymptotes. Don't know which one yet. My other one here says the horizontal asymptote is y equals 0. Well, what does that tell us? That tells us that the degree in the numerator is less than the degree in the denominator, right? So in other words, let's jump to the whiteboard. What did we have? We had let's look, x minus 2, x equals 3, x equals -2, x equals 3. So we know our denominator looks like this. If x equals -2 and x equals 3, our vertical asymptotes, then it must be x plus 2 and x minus 3 down here. Now the fact that it tells us, so these are the vertical asymptotes, the fact that it tells us we have a horizontal asymptote of y equals 0 means if I have degree 2 in the bottom, then I can only have either degree 1 in the top or degree 0 in the numerator, right? And I said top, but I meant numerator. So those are my two options, right? So I can either have something that looks like this, or I can have something that looks like this. So one of these two options based on the fact that the horizontal asymptote is equal to 0. Let's go back and see what other information they give us. Okay, and it says the graph does not have an x-intercept. Okay, let's go back. If I do not have an x-intercept, that means this option is no good, right? Because this thing here would be my x-intercept. I don't want an x-intercept according to my problem, so this one goes out the door. So now I'm only left with this option, right? I'm going to rewrite it down here. I have a over x plus 2, x minus 3. F of x, right? And the question is, I need to know what a is, right? This is probably a common problem issue that we run into when we do these problems. We need to solve for a, kind of the tricky part of the problem. And you need to use all the information, right? It doesn't have an x-intercept, and finally it says it passes through the point -1, +1. So guess what we get to do? Let's use that information. That says right now, if I plug in -1 for my x value, which means I plug it in everywhere, then I should get a +1 coming out. And so if I solve this, right, I get a over, well, -1 plus 2, +1, -1 minus 3, -4. This gives me a over -4 is equal to 1, which means a is going to be equal to -4. Right, so now you've solved for your a value. And so our full function here is f of x is equal to a, which was the -4, and I believe we had x plus 2, x minus 3. And so that's all we need to go type in. Please, again, pause the video, repeat it as much as needed. So we have -4 tab x plus 2 tab x minus 3. Let me double check all that. Yep, that looks good. Good. Okay, let's do one more, because I think that takes us around problem, let's see. That was 5, let's do one more, solving an inequality. And that'll take us 1/3 of the way through, and I'll post the rest tomorrow. Okay, solve the following inequality. We have x plus 8 divided by x minus 1 is greater than or equal to -2. Okay, write that down. X plus 8 over x minus 1 is greater than or equal to, let's see, it was -2. Okay, now the first step is we need to move everything to one side. So we need to move that 2 over. I add 2 on both sides, and I want to have this with 0 on the one side. Okay, now if I want to add 2 things, they have to have a common denominator. All right, so what I'm going to do here is give this a common denominator, so the 2 gets multiplied by an x minus 1 up top and an x minus 1 below. Fancy way of multiplying by 1. Now that I've done this, I can add these 2 together. And they have the same denominator now. And of course, we want to go ahead and simplify. All right, so we distribute the 2. I know I'm going quickly, so again, feel free to pause the video. I know we're already at 25 minutes here and only 1/3 of the way done, so I just want to make sure I get everything covered. And we need to combine like terms, right? So x and a 2x, 3x plus 8 minus 2 plus 6, and x minus 1. Okay. Now, hopefully this seems somewhat familiar, right? So we moved everything to one side, we found a common denominator. Once we find the common denominator, we need to draw a number line. And the things that we want to draw on this number line are going to be x-intercepts and vertical asymptotes. The reason being is because we want to know when this thing switches. This right now is greater than or equal to 0. We want to know when it's switching, right? When it's going from negative to positive or positive to negative, right? And that happens at the x-intercepts and the vertical asymptotes. Well, the vertical asymptotes, let's do this first. This is easy enough, right? We set our denominator equal to 0, and we get x is equal to 1. And so what I'm going to do here is I'm just going to put a line. This is 1, and I'm going to put it dotted. This is a dotted line. Let's circle this one so we know this is different. Okay. Now x-intercepts, all we do is we're going to take the numerator. Let's write this over here. We're going to take the numerator, and we're going to set this equal to 0. Now if we move over the 6, and we divide by 3, we're going to get -2. I'm going to put a hard, solid line here. Now the reason why I'm doing that is because we can actually because there's this equal to here, right? Greater than or equal to 0. We can be equal to this -2, right? But we can't be equal to the 1. The 1 is in the denominator, right? That causes an issue, right? Because of that, we don't want to be equal to 0 because we can't divide by 0. And now what we're going to do is we're going to test these 3 intervals. And so you just need to choose some test points. Now the easiest one that we can choose here between -2 and +1 is x equals 0. So let's see what happens. When I plug in 0, I get 3 times 0 plus 6 all over 0 minus 1. So I get 6 over -1, which is -6. Now I don't really care the fact that it equals a 6. I care the fact that it's negative. And so I'm just going to put a negative here. And I'll even write to myself, this is our test point x equals 0. Well, let's choose a number greater than 1 now. Let's say x equals 2. If I plug in x equals 2, I get 3 times 2 plus 6 all over 2 minus 1. In this case, 3 times 2 is 6 plus 6, 12 over 1. And again, I don't care about the 12, I care the fact that it is positive. And I can leave it to you as an exercise to show that this is also going to be positive. Now the question is asking us, if we read this, it says, well, where is this inequality greater than or equal to 0? And that means I want everywhere that I have a plus sign. So my interval here is going to be from -infinity all the way to -2. Now I can be equal to -2 because I'm allowed to be equal to 0, union, and now I'm going to start at 1. Now the reason why I don't include 1 is because this number is coming from the vertical asymptote and I can't divide by 0. Can't include the vertical asymptote all the way to infinity. Right, so there's our final answer. Okay, I'm going to stop this video. I'll post another one tomorrow. This one might either be posted tonight or first thing in the morning, but at least you have these first 6 to work on. I will see you in the next video.